Okay, so last time we talked about empirical formula, right? And the empirical formula we talked about, let's just start writing. You guys should be able to see me writing this, by the way. And it is recording. So if something doesn't work, then you'll be able to watch this later. Cool. So the empirical formula we saw last time was the lowest ratio of elements in a compound. We saw that, for example, H2O2, that was hydrogen peroxide, we did that as an example. We saw its empirical formula was just HO, right? That's the smallest ratio that we can have between them. Could I just ask someone to say something, just to make sure that you guys are, can hear me? Thank you. Perfect. Okay. It's just a little weird to, be talking. So, cool. Okay, thank you. Okay, so we saw that was the empirical formula. So we're going to kind of work backwards today, and then we'll practice some more with the empirical formula. So we're going to be kind of doing the opposite process. Last time we used the moles of each to find the empirical formula. This time, we're going to go ahead and try something else. We're going to investigate how to get those percents of each compound. And this will be important because, for example, we have sodium chloride. This is salt, right? We know that we have a sodium, we have a dietary amount. And we're going to see that the amount of sodium in salt is not going to be the same as salt. Okay, let's see. Zoe has a question. Looks like Robert's already on it. Okay, so Zoe, with the pop out, it should automatically pop it into a different window. But it looks like Robert is going to answer your question for you. And Manuel, look, we have all these people. So Zoe, out of curiosity, did you press the pop-out thing? Okay, but you're just not able to swap between them? So it should pop out with two separate windows. So, yeah, let's see if Robert can help you. Unfortunately, since I'm the one sharing my screen, normally the pop-out button, is here, and then it should pop out a second screen for you to move forward. Yeah, you are going to have to write in the first window, Zoe. Write and unmute yourself in the first window. The pop-out will just be showing my screen. So everything that's in the one that's showing my screen is my buttons. So you're not going to be able to touch those. So the on the other screen, you're going to be able to type in stuff. So maybe you can make them smaller and put them side by side, if that makes sense. And so we'll see. Okay, hopefully that will have answered that. And yeah, you guys can keep typing there. So if we want to see, we're going to just start with kind of a question here. If we have 5 grams of salt, how much sodium is that? Let's see if we can't work with that. Alrighty, so just so you know, I'm going to be working in blue for when we're actually solving a problem. And I'll be trying to write the problems themselves in black so that it's easy for you guys to look at later. Just so you know. Okay, and I will be saving the notes page as well and uploading that to Canvas, so you'll have that also. So let's see. Okay, you guys are still typing. That's good. Have fun. Let's Let's see. Okay, sorry, Zoe. Yeah, I guess we'll just have to keep working. And then L, yeah, just do whatever you can, and worst comes to worst, you can just watch the recording later. So cool. Okay, so from that 5 grams of salt, we want to see how much of that is actually sodium. And so what we're going to want to start with is, let's find the molar mass of sodium chloride. Go ahead, bust out your phones or periodic tables, whatever you guys need, and let's see if we can't find this out. Do we remember how to do molar mass? We're going to want to do the mass of sodium plus the mass of chlorine, both of which from the periodic table. We're going to be using that atomic mass, remember the one that's on the bottom with all those decimals. So the molar mass of sodium chloride should be, let's see, 22.99 plus 35.45. Thank you guys so much, which is 58.44. Awesome. Unit for that, by the way, AMU, or grams per mole. Remember, those are the same unit. Awesome. All right, and since we want to figure out how much sodium, let's see what percentage the sodium is of the entire molar mass. So let's go ahead and do that. Let's see that we have, if we want to see how much sodium we've got, we're going to want to do mass of Na over the mass of NaCl. Or in this case, just if we're using the molar mass, that'll be 22.99 over 58.44. If someone would not mind doing that math for me. Great, so that's about 39%, or 0.39, whichever way you want to type about it. So, okay, that's just Robert, he's fixing stuff. Okay, cool. So that tells us that of this 5 grams we have, or any amount of sodium chloride we've got, 39% of that will be sodium. So, if we take our 5.0 grams times 39%, we'll be able to get the mass of sodium, which is going to be awesome. Okay, which is 1.95 grams. So anybody out of curiosity know the daily recommended amount of sodium? Some of you are going to be pre-minutes and no, huh? Oh yeah, Samville, we're live. Go ahead and I'll type for him. Yeah, I think it's about 1200. Is it 23? I don't remember either. So, okay, sorry. Let's see. So okay, maybe it's 2.4 or 2.3 grams. So this 5 grams of sodium chloride is almost left side of the screen. Okay, so if you're eating 5 grams of salt, you're going to get just under 2 grams of sodium out of that. So this is important, of course, for people who need to watch their sodium. And then, yeah, so he's looking on the right, I think. Perhaps he's here, we'll see. You guys are awesome. Awesome, awesome, awesome. Yeah, so hopefully that'll help sample out. Okay, cool. Do we have questions on this mass percent thing? We're going to do more of it, of course. That's peculiar. Okay. Type your questions now if you have any, or unmute yourself. Alrighty, cool. So let's go ahead and do the same thing. Oh, by the way, out of curiosity, if the sodium is 39%, what's the chlorine going to be without having to calculate it? Yeah, exactly, 61, and we knew that. Yeah, you're right, Robert. You're right, because it should be 100% put together, right? So if one of them is 39, and since there's only one other thing in there, the other one should be 61%. So, very good. Cool. So, let's do it again. Let's go ahead and see if we take glucose. Let's find the mass percent of all three elements within this compound. First thing we're going to want to do is molar mass. Second thing we're going to do is we're going to take the mass of the element, molar mass of the compound, and since it's a percent, I guess we'll times it by 100, just so it's a nice, easy number. So let's go ahead and do this. So if we want the molar mass of glucose, that's going to be 6 times carbon plus 12 times hydrogen plus 6 times oxygen, which is 6 times 12.01 plus 12 times 1.008 plus 6 times 16.00, technically, which is if I remember, it's something like 180, but let's see. Sarkis is our calculator for the day. Nice. Okay, so about 180.162. Since this stuff is not really experimental per se, we don't really have to worry about sig figs here. Lucky you. So we'll just go ahead and leave that number as is. So if we want to find the mass of each, or the percentage of each element in this compound, we're going to have to do this mass percent thing 3 times. Fine, Robert, go ahead, use sig figs. So, here we go. Oops, we're still doing this problem. So if we're working on carbon, the percent of carbon, we want to do, notice that we have 6 carbons in this molecule. So we're going to want to do 6 times carbon over 180.162. Sorry. Let's see. I'm going to just make that a little neater. Okay. So we're going to use 6 carbons because there are 6 carbons overall in this compound. And so we're going to want to use each one. So we're going to do 6 times 12.01 over 180.162. Hello, new person. Which apparently is 40%. Alrighty. Is that exactly what you got, Sarkis? Or was it like 39.99 or something? Just out of curiosity. I don't actually know the number. Okay. Oh, wow. It really is 40%. Okay, cool. Thank you. Alrighty, so I want you guys to go ahead and do the same thing for hydrogen and for oxygen. So, I will let you do this for, I don't know, a minute or something. And then I will... It's okay, Robert. We're close enough. Maybe he's using 12 instead of 12.01 or something, so 40's okay. We'll keep it like that for now. And since different atomic masses are on different periodic tables, there might be some slight variation, but it's pretty much the same thing. It's weirdly a lot harder to sit still when I'm doing this live. It's pretty interesting. In the classroom, though, I can just shut up and go sit down, but here it's different. Okay, 6.6 seems reasonable. Oh, Zoe, it's, here, I'll write it for you. I will write it in red just for you. That's our chemical compound. Okay, so this looks to be pretty good. Your numbers do look like they add up to 100. However, the 53 again, is that going to be 53 exactly, or are we going to have some decimals there? Oops. Yeah, Robert always has the answers. By the way, Robert is our resident Discord junkie, so he will be able to help you guys out. There is a channel here, Robert's Troubleshooting. If you guys do have questions later, like Zoe, maybe you can go in there and figure out what the hell's happening with your pop-out after class or something. So, thank you, Robert, for being helpful. Cool. So, hopefully Tyrone and whoever will figure this out. But let me just type out to them. Oh my goodness, okay. I'm sorry, by the way, also you're going to hear me click-clack with the typing. I normally do push to talk, but since I'm going to be writing on this thing, you're just going to have to deal with all the random noises, so... I do have 9 dogs, by the way, so it's quite a miracle we've not had any interference so far, so that's good. So, cool. Anyways, so back to chemistry. Yes, Elsa. Okay, so we have 12 times H over 180.162, which is 12 times 1.008 over 180.162, which apparently was 6.6%. And then, I'm going to have to erase our little friend here. I'm going to move this one down just a little bit. So that's going to be 6 times oxygen. That's not a 0, by the way. Over 180.162, which is 6 times 16 over, 180.162, which was 53. Okay, 6.7, fine. Very good. That's okay, Zoe, whatever, it all works. Okay, and who had the right answer? Sarkis, 53.28. Okay, good. Yeah, just because these are percentages, Elsa, we're going to want to multiply by 100. I know we technically didn't last time. We had 39% or 0.39. Those are the same number. But if we wanted it in a percent form, we're just going to multiply it by 100. That just makes these like a little bit easier to use. So, okay. So, these do roughly add up to 100. It's going to add up to 99.98 right now, which is just fine. So that's close enough. But this is cool because this now lets us practice our empirical formula skills from last time. So, let's say we have a compound that is 40% carbon, 6.7% hydrogen, and 53.28% oxygen. Let's go ahead and figure out the empirical formula. I want you guys to go ahead and try this out for a minute or two. Remember, if you're given percents, what are we going to do to those? Exactly. We are going to ignore the percents and pretend those are grams instead. So just so you, in case we've forgotten with empirical formula, we are going to want to convert these all into moles and divide by the smallest number of moles. It is simple, Robert. Trust it. Someone else tried to speak. I love it. Let's see. No luck. Okay. Awesome. Welcome. Okay, I think you guys have had enough time, maybe. So, let's go ahead and pretend that this is 40 grams carbon, 6.7 grams hydrogen, and 53.28 grams oxygen. So, we're going to multiply this guy by 1 mole, or 12.01 grams. If someone wouldn't mind telling me what they got for their moles while I write this stuff out, please. Oops. 16 grams. Okay, 3.33. Okay. How about for hydrogen? Well, you know what, forget it. I already know the answer. I'm faking these numbers because I know what it should be. Right? So, did we all get this, or presumably something close to this? Give or take a couple decimal points. Cool. Alright, so if we divide by the smallest number, that equals 121, which tells us our formula is CH2O. Alrighty. Is that okay? Anybody have questions on that part? If we remember our original formula, it wasn't this, right? It was not CH2O. So, if you remember, we already had calculated the real molar mass of this compound, which was right here. Let's go ahead and see how we're going to get from our empirical formula to our real one. So if the real molar mass is 180.162, let's see what our real formula is going to be, our molecular formula. So we're going to need to find the molar mass Yeah, sorry, Zoe. I think that's kind of what we're going to have right now. Unfortunately, just with computers, that's just probably what it's going to be. Oh, hey, whatever works, you know. Let's see. I don't know if there's any workarounds. Maybe if you have two computers, you could have one streaming and one have the thing open. Maybe. I'm sure everyone is rich enough to have a ton of different, things. Yeah, you could have it on your phone too. That would be another option. I know, no one's made of money, Zoe, unfortunately. Especially now with, people not having... Actually, out of curiosity, I guess if you don't type... That's right, Sarkis. That's the way to go. So... Oh, that's true. Yeah, you do need one more. I like it. I'm glad you guys are having a good time with this. Oh, thank you so much, Arpin. I guess we shouldn't get too distracted. 30.026. Player popped out, huh? Okay, L, that's gonna be okay for now. This will be recorded so you could watch it later, and the notes are gonna be up over later. Okay, that sounds like we have a good workaround for now. So, let's take those two numbers and see what we can get out of them. So, we remember that we want to put the empirical molar mass... Oops. I tried. Over the real molar mass, which is going to be 30 over 180, which is... Oh, I did that upside down. Shame on me. Okay, y'all didn't see that, okay? Aha! (180 over 30). Okay, which is... Math geniuses, go! Really, you guys don't need to calculate for this, trust me. Yay, Marissa! Very good. So, we should then multiply our empirical formula by 6, which gives us C6H12O6. We got 30.06 by doing, I'm going to write it in red because maybe that'll make it clearer. This number we got from carbon plus 2 hydrogen plus oxygen, which is 12.01 plus 2 times 1 plus 16, and that should be 30 point whatever that was. Does that answer your question, Regina? Awesome, cool. Okay. Just, since I'm already watching this screen, you don't have to actually ping me, but if it does not hurt to do so. So cool. Okay. So, and we saw that we did get the formula we started with when we started this whole crazy exercise. Okay, does Shelby have a problem? Let's see. Let's see. The real molar mass number come from. Okay, so that would either be given to you, or since I know that these percentages that we dealt with originally came from this number originally, that's what we're going to be using as our real molar mass. Since we kind of, we broke this compound into percents, and then now we're putting those percents back into the compound. So, yeah, either way you'd be given it, or it would be, provided some way or another. Okay, this is just kind of to show you how you can go back and forth. Yeah, exactly, Manuel, that's exactly what we're doing. So, I was showing you that I'm not just totally BSing this stuff with these percents. It is real. We get the real thing out of it at the end. So, hooray. Okie dokie. Any questions on that? We're going to do maybe one or two more before we move on to the next chapter. Yes. Okay, cool. Yeah, this will be just great. Okay, so, cool. Anyone else have any questions on these? Alrighty. By the way, I still have no idea what's going to happen with your lab, so don't ask me. So good luck. Okay, cool. So let's go ahead and... Oh, you're just going to watch a video, huh? Okay, well... good. That seems to be pretty standard. Oh no. Oh man. Yikes. I'm so sorry about that, guys, but I can't control that, but okay, let's see. So, what were we gonna do? Another compound. Let's see. What is how about we do what's a good compound? Okay, how about this one? How about this one? In 2 chapters we are going to learn how to name these guys, by the way. No uraniums. We're done with uranium for now. This guy is called calcium hydroxide. When we see this parentheses, that means there's a polyatomic ion involved with it. You remember hydroxide from being on your exam? Well, maybe half of you remember it from being on your exam, apparently. So, hydroxide's there, yeah. So, anytime you have a polyatomic ion, and it's got these parentheses around it, this number means there are 2 OH minuses as part of that compound. So, technically, if we wanted, we could write it this way. No one ever would. Don't ever do this. Don't ever write it this way. But for purposes of our empirical formula thing and mass percent, we can pretend it's this way. So, yeah, it is technically wrong because this could be some other compound. Since we want to indicate that these are hydroxide units, we should be putting them in parentheses. But we'll talk about that in a few weeks. Or maybe next week, actually, since chapter 4 is pretty short. Okay, but we can go ahead and use this. Let's go ahead and find the percent of calcium, percent of oxygen, percent of hydrogen. So go ahead and do the same thing we've just done. What's the first step, by the way? Find Molar Mass. Yes, indeed. Familiar mass. Let's see. Let's give you... How about you get a bug? Okay, good. Enjoy. I will calculate our milial mass by myself. 40.08. Yes, you are going to do 1 Ca over the whole thing. This is what I got when I calculated it. There we go, that's the word. That is our molar mass for this compound. Anybody get anything different? I know I am perfect, but sometimes I do mistakes. Yes, we do have 2 oxygens and 2 hydrogens. So the way that this formula is written on the top, that tells us we have 2 of everything in the parentheses. I'm going to make this one a times just so it's a little bit more obvious. Okay, yeah, we should have two of them, right? Because OH parentheses 2 means we have... Here, let me draw it. So pretend that we have like two OHs stuck onto this thing. So overall we have 1 calcium, 2 oxygens, and 2 hydrogens. Sorry, that's really ugly. Let me see if I can fix that. There we go. By the way, if anyone is like colorblind or anything like that, and I'm using colors that are not visible to you, just let me know and I can try and use something else. Alrighty, so what did we get for these three? Wait a second, did I add this wrong? No, it's right. Okay, good. Cool. Cool. Seems reasonable. Or actually, oh yeah, kind of works. These don't quite add up to 100. Yeah, I would say that that one's probably a little higher. Manuel, you failed us. The Molar Mass was wrong. Thank you, guys. The best part is it's here forever, so we can all see the, I guess you could edit it, but that's okay. Everybody gets one. Okay, cool. Wait, so Samville, all we have to do is multiply by 100. I'm sorry, I forgot to write that out. Since these are percents, we're going to multiply them by 100. Okay. Did Manuel just call me a hoe? Yikes. Well, we'll assume he's talking to you, so we're good. Okay, any questions on this one? Let's see. Yes, they should, Robert. Okay. Cool. Let's do one more of these before you guys are completely sick of it. I'm sure you already are, but let's go ahead and do one more for fun. Actually, I'll just hold this one. Does anybody have any questions on this before we move to the next bit? Yes, exactly, Elza. So basically, we're kind of doing the opposite of what we did last time, where we used the percents to figure out the formula of the compound. This time we are going to do the kind of the opposite. This is percent mass, yes. Alrighty. Let's do... Aha, how about this one? Okay. Anybody? Famicent mass. Wow. Okay. So, out of curiosity, just to put this in your head, anybody know the name of this guy if it had a plus sign? And how about the other side? Yeah, not quite. Shame on all of you. Yay, Robert, yay! Just so you know, this formula is called ammonium nitrate. it's in fertilizers and explosives and stuff. This is the stuff that they, yeah, nitrite has the 2 subscript. Yeah, NH4NO3. Sorry, it's, yeah. Anyways, we're going to learn how to name these things, but stuff like this, where it's just polyatomic ions, it's very easy. It's just the name of both of them put together. Cool. Okay, yeah, so if you try and buy a lot of this, you're going to be placed on a special list, and people will come and accuse you of making bombs. So cool. Let's find out the percent of... How many elements do we have in this, by the way? Aha, I tricked you. There's only 3. Yeah, very good, Elsa. Since there are 2 nitrogens, technically. So, let's go ahead, find the percent nitrogen, percent hydrogen, percent oxygen. Just so you know, there are 2 nitrogens in this molecule, okay? So don't forget about that. Okay. Yes, that would be correct, Robert. Okay, cool. Someone has calculated the molar mass for me. Oh no. Oh no. Okay. I know, so true. Let's see. So, fun question. Molar mass is AMU or grams per mole. They're the same unit. So, those 2 are the same unit, yeah. .046. .1, or that thingy. Correct, Robert. Oops, sorry guys. Yeah, that's probably right. That seems pretty reasonable. Do we agree? So while we know we cannot trust Manuel, the rest of us should be trustworthy. That seems to be pretty good. Indeed. That is exactly correct, Robert. Real questions. So, fun facts for the day. You know, you, as a human, are mostly oxygen by mass. Like, completely by an, way, a huge margin. Mostly because we're mostly water, and water is 89% oxygen. So, and then of course all your proteins and sugars and everything else have oxygen as well. The Earth is also mostly oxygen. So, again, mostly because of all that water, but all those rocks are like silicon and oxygen compounds, aluminum and oxygen compounds, so oxygen is actually pretty much the most abundant element by mass on the planet. Indeed. Alrighty, anybody have any questions on this mass percent stuff, by the way? Alright, that means I've got to check it now. Okay, so 2 times 14.01 divided by 80.046. I got roughly 35. So Shelby, yeah. Apparently we got 0.046 on this one. Just depending on what periodic table you're using, it might be slightly different. So, but this one is very close, yeah. So, Zoe, I did get 35%, so go ahead and check your things again. Oh gosh, sorry. My headphone just ruined everything. Okay, cool. Okay. Last chance for questions on mass percent. Yes, Robert, that's correct. We're going to add the 2 nitrogens and the 4 hydrogens and the 3 oxygens together to get 80.046 or 052, depending what you're using. Yeah. Okay. That's all right. You figured it out. That's awesome. If you can believe it, the next chapter will not even have sig figs. How sad will that be? But we'll get back to sig figs. I know. You guys are all going to be... They are just barely leaving you. It's just for like a couple minutes, so we'll see. Yeah, exactly. Sad day for sig figs. Good, I'm glad they're haunting you. Alrighty. So, just thinking about this, do we still want to do like a break, for online stuff? I will put that as a poll. Okay. Break, yes, frog, no, bug. Okay. Let me, I will vote for my own. I'll do both. Just so you can have them both. Who the heck put watermelon? L. No watermelons. That's okay, L. Okay, the watermelons are so far gonna win. Let's see here. You know what? Fine, forget it. I will also vote watermelon. I have no idea what the watermelon is for, but it's gonna win. So... yeah, watermelon break. I have to go buy watermelons for everyone. I know. Well, I only have 2 of them in the room with me, and they're both fast asleep, so... okay, so, we'll continue this later. Once I get the webcam, perhaps I'll have guest stars, with me. I know, we all need refills on snacks and stuff. So, okay, so we are going to take a break. Looks like the watermelons have been victorious. So, it'll be about 10 minutes, so we'll say 4:32. And so I'm going to go ahead and stop the recording as part 1, and then I will upload that to YouTube, and I will save this written stuff also. Okay? So I'm going to just, like, mute myself or go hide for 10 minutes so I can also get a break. So cool. Okay, see you guys at 4:32.